Hi. So our lesson for today is about graphing quadratic functions. So first, I'll define what a parabola is. So a parabola is a special curve shaped like an arc, and any points on the parabola is at an equal distance from a fixed point, which is the focus, and a fixed straight line, which is the directrix. So why am I defining what a parabola is? The reason is that parabolas are graphs for second degree polynomials. So for your quadratic functions, mostly the graphs that you will see are parabolas. So let's have a sample here. So we have y is equal to negative x squared minus 2x plus 3. So first we need to understand that for this particular quadratic function, we have what we call a vertex form. So a vertex form is something like a multiplied by x minus h squared plus k. So why is it called vertex form? The reason is that for this formula, you can define your vertex using h and k. So I'll show you how we can derive the formula for h and k using the quadratic function ax squared plus bx plus c. So we need to derive the formula for h using the coefficients a, b, and c. So first we have to factor a from this one. So we'll have a being factored here, and it will result to x squared plus b over a times x plus c. The next part is we have to complete the squares. So for this term, we have to get the half of this term, which is b over 2a, and then square it, resulting to b squared all over 4a squared. So if you add this one inside this particular formula, we can see here that what we really added is b squared all over 4a squared multiplied by a, which is b squared all over 4a. So if it's like adding b squared all over 4a on this part and then subtracting b squared all over 4a on this part. So if we add something, for example, we add 4, we need to subtract 4 so that we can maintain the value of this function. So the same thing here. So we've added b squared all over 4a inside, and then we have to subtract b squared all over 4a on this side. Thus, we now have the equation a x minus b minus negative b all over 2a squared plus c minus b squared all over 4a. So this one is the vertex form. So we can look here, the formula of h as represented by the coefficients will be negative b all over 2a, which is the most important part to remember, the most important formula that you need in order for you to graph your quadratic function. And then k here is represented as c minus b squared all over 4a. So we now have our vertex point hk. So let's apply it. So going back to our example, we have y is equal to negative x squared minus 2x plus 3. So as mentioned, h is the most important formula that you need to remember, which is negative b all over 2a. So arrange your quadratic function first from highest to lowest exponents. So this one, now we can identify that a is equal to negative 1, b is equal to negative 2, and c is equal to 3. So using the formula of h, we can substitute this a, b, and c to compute for your variable h. So this will be negative of negative 2 divided by 2 times negative 1, which will result to negative 1. So we now know our h as negative 1. So as mentioned earlier, you just need to memorize the formula for letter h, or for variable h, because by substituting h to your x variable, you can now solve for k. So let's try to substitute negative 1 to x. So negative 1 squared minus 2 times negative 1 plus 3 will result to negative 1 plus 2 plus 3, which is equal to 4. So we now have our k as 4. Thus, our vertex is negative 1, 4. So we now have one of the important points in your parabola, which is the vertex. So what we need is to get 2 more points. So given that our vertex is negative 1, 4, and your x component here is negative 1, you have to get the left and right number from negative 1. So you can get any number from on the left side or on the right side of negative 1, but for simple computation, let's get the first integer on the right and left side of negative 1. So on the right side of negative 1 is 0, and on the left side of negative 1 is negative 2. And we substitute it to our x. So if x is 0 and x is negative 2, by substitution, we get y is equal to 3. So we now have 2 more points. So aside from the vertex of negative 1, 4, the other 2 points is 0, 3, and negative 2, 3. So if we graph our quadratic function, the vertex here in the yellow highlight is negative 1, 4. On the green highlight is 0, 3. So 0, 3. And the purple one, negative 2, 3, is negative 2, 3. And as you can see here, the parabola is opening downwards because the coefficient of your first term is negative. So another sample where we can see the difference on the coefficient is this one. So as we can see here, the coefficient is positive 1, thus having our parabola opening upward. So I hope we can now graph our quadratic functions easily. So this is just one of the many techniques that you can use to easily graph quadratic functions. Thank you and God bless.